Swayam Prabha. Digital India. Educated India.
Welcome back, learners. The video is for the subject of Geography for the course of Bachelor's in Arts with Geography or Bachelor's in Arts with Honours in Geography. The video is for the paper of Climatology. Today we are going to start second lecture of Module 3. The topic of the lecture is Wind Circulation, Forces Governing the Wind Circulation and Their Global Significance. The video is being recorded by Dr. Pallavi Upreti. The course coordinator and presenter for the video is Dr. Pallavi Upreti, affiliated to Department of Geography, Doon University. The academic expert and reviewer for the video is Professor Santosh Verma, Head of the Department, Department of Geography, SDM-PG Government Degree College, Doiwala, Dehradun, affiliated to Shri Dev Suman, Uttarakhand University. The video is produced and presented under the project name DTH Swayamprabha Channels of MHRD, New Delhi, India. Hello dear learners, I am Dr. Pallavi Upreti, Assistant Professor in the Department of Geography in Dr. Nityanand Himalayan Research and Study Center, Doon University, Dehradun. Today we are going to start with the second lecture of Module 3, and in the previous lecture we have already discussed what is atmospheric pressure and how the pressure belts affect the global climatic conditions, how the shifting of pressure belts leads to dynamic climatic conditions. And in this particular lecture we will be discussing what are winds. What are the factors which lead to the formation of winds, and in general we will be discussing the circulation of winds. So let's begin. The main objective of this particular video is to understand what are winds in general, understanding the general wind circulation and movement conditions. Then we will understand how the strength and direction of winds is measured, what are the various instruments, what are the techniques, and then we will move on to study what are the forces which affect the general circulation of winds. And finally, we will be discussing wind circulation and its global significance, how the circulation of winds impact the various climatic and weather conditions across the globe. And we will even discuss the importance of wind circulation in climatology and in studying the weather and climatic systems across the globe. Starting with the simple question, what is wind? Wind is the movement of air. More specifically, it is the horizontal movement of air. And this movement of air is one of the main driving forces governing weather and climatic conditions across latitudes. It may range from a calm light breeze to a severe hurricane storm force with catastrophic impacts. Therefore, the study of wind system is fundamental to climatology since it defines the general atmospheric circulation that exists on our planet and how that atmospheric system has evolved over space and time. Wind is the horizontal movement of air caused by differences in air pressure in different regions within our atmosphere. So air moves because of variation in air pressure, or it can be density of air also, or it can be both. Such pressure and density variations are mostly caused by differential heating of air near the Earth's surface, which depends primarily upon the insolation received in different regions of the world. So differences in air pressure is primarily the outcome of uneven heating of the Earth's surface. So as we know that the lower latitudes receives high insolation, therefore they have high temperature as compared to the higher latitudes which receives less insolation, therefore they have less temperature. And this temperature difference across latitudes leads to differences in air pressure also. Besides temperature variations, we have also studied when we were doing the pressure belts of the world that besides temperature, there are factors like rotation of Earth which also play a significant role in defining the pressure regions across the globe. So you have factors which are related to temperature, and then there are factors which are related to Earth's rotation, which define the pressure regions of the world globally. So you have high pressure belts and high pressure regions, and then you have low pressure regions over Earth. And the movement of air primarily occur to equalize the differences in the air pressure between two adjacent areas. So air molecules in high pressure zones are closely packed together than in the low pressure zones. So gas molecules in high pressure zones tend to spread out towards the low pressure zone, resulting in the movement of air from high pressure areas towards the low pressure areas. Therefore, the movement of air is always from high pressure areas towards the low pressure areas. As you can see in this diagram also, the high pressure areas, here the molecules of air are compacted together, which tends to spread out near the Earth's surface and move towards the low pressure regions. So low pressure regions act as a magnet which attract the air from the high pressure areas. Therefore, their movement of air is always from high pressure towards the low pressure. And it is true not only at the global level but also at the regional or local level. Wherever a low pressure center is created because of high temperature or because of factors other than temperature, the winds are attracted towards that low pressure center. The winds are pulled towards that low pressure center from the high pressure center. So high pressure center are the regions where wind diverge, and the low pressure center are the regions where winds converge. At global level, the existence of significant pattern of pressure that persist latitudinally over time are called as pressure belts. So in the last lecture, we have thoroughly discussed what are the pressure belts, how do they evolve. There can be thermal reasons and there can be dynamic reasons which leads to the evolution of specific pressure belts. So latitudinally, 7 pressure belts exist on our Earth which are thermally induced, and few are dynamically induced. So you have equatorial low pressure belt extending from equator to 5 degrees north and 5 degrees south, and it is a low pressure belt and it is thermally induced. And then we have subtropical high pressure belts which is located somewhere around 30 degrees north and 30 degrees south in both the hemispheres, and it is dynamically induced. Similarly, we also have subpolar low pressure belts extending somewhere around between 60 degrees north and 60 degrees south latitudes in both the hemispheres. And again, this is dynamically induced because of the rotation of Earth. And finally, we have polar high pressure belts which extend beyond 80 degrees north to 90 degrees north in the northern hemisphere, and then 80 degrees south to 90 degrees south in the southern hemisphere. And this is thermally induced. So these are the 7 pressure belts. We have discussed them in detail earlier in the previous lecture. So just giving you a brief of them here. So the equatorial low pressure belt is thermally induced, and polar high pressure belt is also thermally induced. The rest of the belts in between, that is the subtropical high pressure belt and subpolar low pressure belt in both the hemispheres, are dynamically induced. And these pressure belts, on an average, they remain stationary. However, they shift with the apparent northward and southward movement of the sun during the summer solstice and winter solstice. And air near to ground surface moves horizontally from regions of high pressure towards the regions of low pressure. So from the high pressure belt areas of the world, the winds will always move towards the low pressure belt regions across latitudes. Besides horizontal movement of air, the atmosphere also have vertical movement of air, which is primarily convection induced. Because of the intense insolation, the air near the ground surface is heated tremendously and is forced to ascend and rise up. And in the process, it condenses, leading to precipitation. So besides the horizontal movement of air, which is called as wind, you also have vertical movement of air, which is primarily induced because of convection. So you have local upflow of air and downward flow of the air, which is called as updraft and downdraft respectively. But primarily the winds are associated with the horizontal movement of air. It can be of global nature, it can be of regional nature, and it can be of local nature. So let's just quickly see, depending upon the various pressure belts of the world, how the general circulation of wind will look, and how this general circulation on Earth's surface is aided by the atmospheric air pressure conditions in the upper atmosphere. So as you can see by rule that air always blow from high pressure regions towards the low pressure regions. So near the Earth's surface, the subtropical high pressure belts, because they are high pressure belts, it will lead to the divergence of air. The air will blow out from these regions near the ground surface, and one wing move towards the subpolar low pressure belt because it is a low pressure belt, and another wing move towards the equatorial low pressure belt. Same process will also happen in the southern hemisphere. And you can also see for polar high pressure belt regions, again they are the high pressure regions, so winds will again blow out from these regions towards the low pressure regions in both the hemispheres. So let's not go into the details why the direction of winds is specific. As you can see, they are tilted specifically in a specific direction because we will be covering them in the coming slides. So just take for now that the winds always move from high pressure regions towards the low pressure regions. And this phenomenon on the ground surface is immensely affected by the air pressure conditions in the upper atmosphere also. So if you have a low pressure center at the ground surface, it will lead to convergence of air at the ground surface. And opposite to this, you will have a high pressure center in the upper atmosphere, which will lead to the divergence of winds in the upper atmosphere. Opposite to this, if you have high pressure center at the ground surface, it will be characterized by divergence of winds at the ground surface. And opposite to this, you will have a low pressure center aloft, which will lead to convergence of winds. So just replicate this in the global pressure belt map. If you have a low pressure center at the ground surface, you will have a high pressure center above the equatorial areas in the upper atmosphere. So low pressure center at the ground surface is marked by convergence of winds, and once they converge, they tend to rise up. And once they reach a specific height in the upper atmosphere, they diverge because of the existing high pressure. Besides this, if you have a high pressure at the ground surface, you will have a low pressure in the upper atmosphere, and this low pressure will lead to the convergence of air in the upper atmosphere and divergence of air at the ground surface. So this applies for all the different regions. So again, you have a low pressure center. Above this subpolar low pressure belt, you will have a high pressure in the upper atmosphere, which will lead to divergence. So this process applies to both the hemispheres. Wherever you will have a low pressure region at the ground surface, it will have opposite conditions in the upper atmosphere, which will aid and maintain the pressure zones on the ground surface, and hence it will affect the general circulation of winds also. So in this particular animation, you can see how this process actually happens, that the low pressure center is actually marked by the convergence of winds. And once the winds converge, they tend to ascend, and in the process, they condense. And because of the presence of high pressure in the upper atmosphere, the winds tend to diverge in opposite direction. Besides this, you can see that if you have regions of high pressure, so high pressure regions are marked by divergence of winds at the ground surface and convergence of winds at the upper atmosphere because of the presence of low pressure. So before starting, what are the forces which affect the intensity of winds and how are the winds classified? We have to first understand that how do we measure the strength and direction of winds. So on a short time scale, the wind can actually indicate which way the weather is proceeding, whether it is going to remain calm or it is moving towards the development of storm, or even it can assess the intensity of storms. Also, how impactful they can be, to what extent they will lead to disaster, and so on. So wind speed and directions are among the most important measurement in the study of weather systems. So how do we measure wind speed? Wind speed is measured with the help of an instrument which is called as anemometer. So this type of anemometer instrument has a spinning wheel. The stronger the winds blow, the faster the wind rotates. The anemometer counts the number of rotation which is used to calculate wind speed, and once calculated, the wind speed is expressed in units of distance per time, that is kilometer per hour, or simply as knots also it can be expressed. Besides wind speed, the wind direction is measured by a weather vane or wind vane with marked primary cardinal directions on it. So this is weather vane. Just observe the marked cardinal directions, north, south, east, west, and it conveys the direction from which the wind is blowing. It is reported in either cardinal directions or simply degrees also. Another device which measures directions is the windsock, which uses a large cloth tube that extends depending on the wind speed and direction. It is possible to use multiple wind vanes also, which are spread across many locations to determine the broad wind profile of a geographical region, especially when they are installed with anemometers. So the combination of an anemometer and a wind vane mounted together is often called as aerovane. And this type of setup is often seen today in weather stations which keep record of wind direction and speed. Wind direction and speed, when assessed over a long time scale, they indicate the general atmospheric circulation pattern, which is a key aspect of climatology. Therefore, it becomes imperative to measure the strength and direction of winds. Now, coming to the forces that affect the wind circulation. Fundamentally, there are three forces that generate winds and affect their circulation. First one is the pressure gradient force, which is the primary wind generating force. Second is the Coriolis force, which is the wind deflecting force. Third is the frictional force or the friction, which is a wind restraining force. So let's see one by one how these forces affect the wind movement and circulation. Starting with pressure gradient. Pressure gradient is the primary wind generating force which exists due to the differences in air pressure between the two places. The direction of pressure gradient is from high pressure to low pressure, and it is always perpendicular to the isobars. So it is the primary wind generating force and it is always perpendicular to the isobars. So this primary wind generating force defines the flow of air, which is primarily from high pressure regions towards the low pressure regions following the pressure gradient, also called as barometric slope. So as you can see in the diagram that the low pressure areas are the regions where you have convergence of air. So the air always moves from the high pressure regions towards the low pressure regions. So it defines the direction of wind movement. As you can see that in this particular diagram, it is moving from east to west. So the direction of wind is defined by the pressure gradient force. Besides the direction of wind, the wind speed is also defined by the pressure gradient force. Because the higher the pressure gradient force, the isobars will be more compacted and it will reflect steep pressure gradient. Strong winds will blow in those areas where the steep pressure gradient exist, where the isobars are closely compacted together, and opposite to this, light winds blow in the area with slow speed where the pressure gradient is gradual and isobars are loosely compacted. So the pressure gradient is the primary wind generating force which exists due to the differences in air pressure of the two places, and it not only defines the wind direction, which is primarily in the direction of low pressure region from the high pressure region, but it also defines the wind speed, which is greater with the steeper pressure gradient and it is lighter with the gradual pressure gradient. So because of these differences, it creates regions of high wind speed and regions of low wind speed. So this is how the pressure gradient force affect the wind generation and overall wind circulation. Besides pressure gradient force, another force which impact the deflection of winds and which affect their circulation is the Coriolis force. This particular force is the deflecting force. It does not create winds, but it deflects them once they are already in motion. And this Coriolis force is the apparent force that occurs due to the rotation of Earth. So the rotation of Earth from west to east on its axis in approximately 24 hours of time periods leads to this Coriolis force. Therefore, it cannot create winds, but it can change the wind direction by deflecting them in different directions. So as we know that the whole Earth completes its one rotation in 24 hours, moving from west to east. And as the Earth is widest at equator, the speed of rotation at equator is maximum than it is at the polar areas. So the rotation speed of Earth is highest at equator and it decreases as you move poleward, because of which the Coriolis force, as it is directly proportional to the angle of latitude, it is zero at equator and it is maximum at poles. Because at equator the forces cancels out each other, hence the Coriolis force at equator is zero and it increases as we move towards poles. So you have to understand this: when the wind moves either northward or southward from the equatorial areas following the straight path, it does not reach its destination, because by the time the destination place has already moved ahead and the wind lag is created because of high rotation of Earth at the equatorial regions. Contrary to it, the wind moving either northward or southward in the higher latitudes reaches ahead of its destination because of decreasing rotational speed of the Earth at the polar regions. So, based on the deflective forces, Ferrel has said that if one stand with one's back towards the direction from where the wind is coming, then the winds tend to deflect towards their right in the northern hemisphere and to the left in the southern hemisphere. So based on the origination of the wind and then their direction, if you see, so from the origin point, the winds are always deflected towards their right in the northern hemisphere and they are deflected towards their left in the southern hemisphere, because of which you have anti-clockwise circulation of winds in the northern hemisphere and you have clockwise circulation of winds in the southern hemisphere. So all the winds, no matter in which direction they are moving, whether they are coming from equator or they are coming from polar areas, they will always deflect towards their right in the northern hemisphere and they will always deflect towards their left in the southern hemisphere. So this is how the Coriolis force deflect the wind circulation in different hemispheres. Now, besides Coriolis force and pressure gradient force, you have friction also, which affect the wind circulation. As it is typical for nature, some forces act to cause movement, other forces exist to resist that particular movement, and friction act as a resistant force which affect the wind circulation. And it primarily occurs when flowing air interacts with the Earth's surface. Air blowing near the Earth's surface, especially up to the height of 1 kilometer, is restricted because of friction along the earth and air interface region because of several topographical factors. So friction with Earth's surface, whether land or water, causes the wind pattern near the Earth's surface to become more complicated. So near the Earth's surface, when the air interact with ground, some of it is forced to ascend a topographical barrier just like a mountain, or it may also descend in the valley region, or it may circulate around trees or buildings or other constructed features. So as a result, the flow patterns becomes curved, complex, turbulent, and it may flow like eddies in the flowing rivers also. This friction is dominant restrictive force which is confined to 1 kilometer layer above the surface of Earth where it is maximum, and this layer is called as the frictional layer also. And as you move up altitudinally, the friction reduces because the interaction between the Earth's topographical features, constructed buildings, and other features is reduced as you move up in the atmosphere. So stronger winds occur aloft because these areas are located further away from the frictional effect of the Earth's surface. But even within these regions, also in the upper atmosphere, sometimes because of certain factors like sudden updraft of air or downdraft of air, because of differences in the movement of air, different pace and different direction, the friction can also accompany the vertical air movement with the updraft or downdraft. So if you have a very strong upward drafting current, it may lead to restriction in the horizontal movement of air even in the upper atmosphere. So friction is highest near the ground surface, and then it decreases as one moves towards the upper atmosphere where you have stronger wind movement. But sometimes because of certain conditions, because of updraft, downdraft, this upper atmospheric wind circulation is also affected. So friction can also accompany vertical movement in updrafts and downdrafts. So friction not only impact the speed of winds but also deflect them, because as it causes restrictions in the movement of air, it is definitely affecting the speed. But because of the interaction with the various topographical features, the movement of wind sometimes becomes very complicated. It may lead to curved, circular, eddy-like movement of winds in different areas where they interact with different aspects of Earth depending upon the level of interaction, where they interact with the various features which are present on the Earth's surface. Now coming to wind circulation and their global significance. Understanding wind movement is very significant for climatology as it is the major driving force for weather conditions across areas. It can be at local level, regional level, and global level. And the majority of weather events like precipitation, cloud formation, and even the extreme weather events like existence of cold, warm, dry weather systems, formation of fronts, formation of thunderstorms, cyclones, hurricanes are all driven by the wind circulation, which can be again at the regional level, at the global level, and at the local level. And at the global level, the wind circulation helps in the redistribution of heat along the latitudes, thus maintaining the global latitudinal heat balance, and it maintains the overall heat budget of the earth, thus maintaining the average temperatures on earth, which is very important for the sustenance of life, for the evolution of flora, fauna, and even human beings. Therefore, the study of wind systems, their circulation pattern over time at the global, regional, and even at the local level is the key factor in indicating the general atmospheric circulation pattern of any area and thus defining the climatic regions across latitudes, which is a key aspect of climatology. So when we talk about climatology, the study of wind pattern, movement, direction, speed becomes very important because it defines the general circulation pattern of any area, it defines the climatic conditions of any area, it defines and governs the precipitation regime of regions across latitudes. So the study of winds is very essential. Summarizing the video now, wind is the horizontal movement of air which is primarily caused because of the differences in the existing air pressure in different regions of the world within our atmosphere, and air near the ground surface move from regions of high pressure towards the region of low pressure, and this movement of air can happen at global level, regional level, and even at local level. So the air near the ground surface tend to move from regions of high pressure to low pressure primarily in order to equalize the existing pressure differences between the two adjacent areas. And this periodic movement of air pressure is generally measured by using various instruments. Like the wind speed is measured with the help of instrument anemometer, and the wind direction is measured with the help of wind vane or windsock. So measuring the periodicity of winds, the intensity of wind is very, very crucial in climatology because it defines where the climatic conditions are heading, whether they are going to remain calm or they may develop into intense systems which may impact the life of people also. So the periodic measurement of wind is very essential. Fundamentally, there are three major forces which govern the wind circulation. First one is the pressure gradient force, second is the Coriolis force, and third is the friction or frictional force. While the pressure gradient force primarily is the wind generating force, is the basic wind generating force, and it defines not only the velocity of winds but also the direction of winds. So the winds generally follow the barometric slope or pressure gradient and move from high pressure areas towards the low pressure areas. So the pressure gradient force generate the winds. Besides pressure gradient force, another force which affect the wind circulation is the Coriolis force, which is produced because of the Earth's rotation. So it is not the wind generating force, it is the wind deflection force because it acts only on the objects which are already in motion, because of which the winds are deflected towards their right in the northern hemisphere and they are deflected towards their left in the southern hemisphere, making the entire wind circulation in the northern hemisphere to be anti-clockwise and in the southern hemisphere to be clockwise. Then you have frictional force or simply friction, which restrict the wind movement resulting from air-earth interaction. And this force is maximum near the ground surface while it decreases with altitude. So you have high speed wind circulation in the upper atmospheric region because of the low frictional force. So these are the primary forces which affects the wind circulation, wind generation. Besides this, the importance of studying wind system, their circulation pattern over time at global and regional level is very, very essential because it is the key factor in indicating the general atmospheric circulation of any area, and it is important in defining the overall climatic zones of the world also, in understanding why certain types of climatic conditions and weather patterns are found in certain regions of the world and why there are differences in the climatic conditions across latitudes. So they help in defining the climatic zones also. Therefore, the study of wind system, wind circulation, its intensity, its speed is very crucial aspect when we study climatology because it is the major factor which defines the atmospheric circulations across latitudes at the global level also, at the regional level also, and even at the local level also. So it has a very wide variations in affecting the climate and weather conditions of any area in governing the macro as well as micro weather conditions of any area. So this was all about the winds, their circulation, forces which affect the wind's circulation, or what is the significance of understanding wind systems and how do they define the general atmospheric circulation of any region of the world. I hope the video was informative. Thank you so much.